Hello guys, welcome back again to my channel yet with another amazing tutorial. In today's video, we are going to plot histogram in Python. So I will go step by step what libraries we are going to import, how we are going to generate data, how we are going to plot histogram, and how we actually can further add details into our plot that will actually help us convey better meaning to stakeholders or supervisors or teachers through effective plotting techniques. So let's start this tutorial. So first of all, for libraries that we are going to use to plot histograms are matplotlib, which is a powerful Python library that used for data visualization. And secondly, we are going to use numpy, which is actually used to generate random set of data. So first of all, let's import our matplotlib, and we are going to use the module pyplot. So we are first calling the matplotlib library, and we are using dot notation to call the module pyplot, and then we are setting it as plt. Then we are going to import the second library, which is numpy, and we are using import numpy as numpy. So we have imported our libraries. Now let's generate a random set of data that we can actually use to generate histogram. So you might be wondering what is histogram. I will explain in a detail when actually we are discussing about visualizations and bins and what actually histogram represents. So in order to now get back to the generating random data. So in order to generate random data, okay, random means like the data is randomly distributed. We are going to use the function np, random.normal. So we are going to use this function from numpy and to generate random set of data, and we are passing three input arguments to it. The first one is loc is equal to 50, the second one is scale is equal to 10, and this last one is actually size is equal to 1000. So first of all, let me discuss about the size equal to 1000. So it means that it will generate 1000 data points. So this the third argument, it means that. Now let's talk about loc and scale. So the loc is equal to 50. It means that it will generate 1000 randomly distributed data points that has a mean of 50. So that's here we define we want randomly distributed data point that has a mean of 50. And the second input argument is actually scale is equal to 10, is actually the standard deviation, how the data is deviated from the mean. So we have mean, the standard deviation, and then the size. And we are generating those random distributed data, and we are storing in it variable data here. Now we have a data here. So let's move on to actually plotting this data into an histogram. For this purpose, we are going to use the function hist from matplotlib. So we will use plt.hist function. Then we have a very detailed and lengthy input arguments. So I will explain it bit by bit and every input arguments in details so you can understand it. So don't get overwhelmed by it. So this is likely the main plotting command that we are going to use to plot histogram. And the first thing we are passing it as is data, which is our randomly distributed data point. So the first thing we will pass it as is the data points here. Now the second input argument is actually bins is equal to 30. So bins is actually the range of data points on which we want to create histogram. So basically what we do mean by histogram, let me just show you the picture here. So suppose that you have 1000 data points that are randomly distributed. Now we will create a bin, for example 0 to 5, 5 to 10, 10 to 11, or 15 to 6, 20, and so on. So we will create ranges, and then we will count, okay, within that range how many data points are actually present within this randomly distributed data. So we will calculate the frequency of occurring, and based on those that frequency will ultimately define the height of these bar charts here of histogram. So how many times this range of data points were found in our data set. So that's what is actually means by histogram and bins. So when we define bins is equal to 30, we are actually creating ranges from 0 to 30, 31 to 60, and 61 to 90, and so on. So and then we will calculate how many data points are actually present within each bin. So we actually have like discussed the first and the second input argument. Now the remaining input arguments are important, but they are not as important as the first two. So I mean the remaining input arguments are just for the statics, and which are also quite necessary. The first, the third input argument we are defining here is called color. So we are in our case we set it like light green. You can set it to anything like light blue, light red, and anything. After that, then we again define the edge color is equal to black. So basically each bar chart here will have black line as outlined. Then we have like alpha is equal to 0.7. It means for the transparency, like we are defining like we want 70% transparent plotted histogram. And you can also actually see that these lines are actually visible behind the histogram. So that's what happens when you like declare a transparency of 0.7 or any value is that you want to actually plot it. So this is actually the main command line that we are going to use to generate histogram. And now let's move on to actually how we can actually populate our plot or any plot, instead of like we have specifically were talking about histogram. You can actually take any plot and then like populate with useful and necessary information. So let me discuss that. So the first level of information is actually the x-axis, y-axis, and titles that defines okay what are like the x-axis, what are the y-axis, and what is actually the main title of the plot. So for this function, like for this thing, we will going to use like function x label, y label, and title. In x label we have values. You can see that here. Values means bins, the ranges we define here. And then we have y values, we have frequency of the specific data falling within a specific bin. So we have frequency, and we titled anything like customized histogram because as you see, like it's a customized histogram with colors and edges, and transparency has been customized. Okay, this is how you actually define labels and titles. Now the second thing we can actually add into our plot is actually adding grid line. For this function, for this like purpose, we are going to call the function grid, and we will set this value as true because by default it's false, but we will set it as true. And then later we will pass two more input arguments that actually defines the characteristics of those grid lines. The first input argument is like line style, which is like double dot. It means that we want dashed line. And the last input argument is like alpha. Again, alpha is for transparency, and we are setting its value to 0.5, like we want it 50% transparent. So you can actually see that these grid lines are quite blurred and like very light, so they are transparent. And now we have like defined our labels and titles. We have actually added grid lines. So we actually do have a very good looking chart. But let's say you want to add some further necessary information that is quite important for your audience to understand this plot. So we are going to use text annotation that helps you add any text, kind of text within the plot. And in order to like actually add text, we are going to use the function dot text here. Then we'll pass some input arguments. It's a bit lengthy, but let me explain it bit by bit. So within those function, like within that function, we will pass the coordinates of the block or the text we want to visualize in our plot. So as you can see here, like we have defined 65 and 70. 65 is for x-axis and 70 is for y-axis. So you can actually see that this box actually starts at 65 and starts at 70, around about somewhere close. So this is how you actually define, gives the coordinate where you want this text or block of text to be displayed in the plot. Then the second input argument will be actually the text you want to display. In our case, we know that this randomly distributed data point is actually has a mean of 50 and a standard deviation of 10. So this is how you actually define the input argument. Then we have font size. What will be the font size of this text that is displayed in the box? And finally, we have here some characteristics of the box. Okay, so what is the color of a box behind the text here? In our case, we set it to white, and we also set its transparency is equal to 50%, like we want it 50% transparent. And finally, we will call the function show that will actually use all those things that we have actually defined to show the plot. We have defined, like we actually have used hist function to plot the histogram, then we have defined labels and titles, then we have added grid lines, and then finally we have added text annotation, and then finally we have plotted histogram. So this is how you actually plot the histogram. Let me just run it for you. So this is our histogram. So you see it here. Now, I think that's like you already know like how to plot a histogram, and also to add further information into your plot, whether it's a histogram or any other plot in Python. So right now I'm more interested in actually like to know what is the kernel density estimate of this data point. So it will be like not any different thing. So we are going to use another library which is Seaborn, and we are going to import it as import Seaborn as an SNS, and we are going to use its function histplot to actually plot the histogram and also the kernel density estimate. So basically all the code will remain same as the first one, but except of actually using this function from matplotlib, we are going to use the function from Seaborn, that is histplot, and we will pass the same input argument like the data beans and the color and edge color and alpha, but in our case we are going to set kernel density estimate is equal to true. So basically it will also plot the kernel density, population density estimate here. So basically it's a kind of probability estimate, like what is the probability of occurring this data point within a data set. So this is how you actually plot it. So we are going to use hist.plot and data, when define the input arguments data bins KDE is equal to 2. We want to plot the kernel density estimate. Then all the things remain the same. The label and titles will remain the same, except for the title. Now we are plotting the histogram with kernel density estimate, and the grid lines will remain the same, and in a text annotation is the same. I mean, we know that this is the data with the mean 50 and standard deviation 10. And finally we will call the function show here. So now you can see that now we have actually the histogram based on our visually aesthetic inputs, like we want green color, we want transparent, we want black lined, and then we also plotted the kernel density estimate, and then we've also added the mean and standard deviation. So I think that's it for now. I mean, this is a detailed tutorial, and right now you are able to plot it without any issues. And if you have still any questions, like you can just comment down and I will be happy to help you. That's it for now, and stay tuned for more data visualization tips and tricks, and I will also be plotting, like giving tutorials about Tableau. So stay tuned.